Okay, this is the lecture video for MAT 1100. This is lesson 1.7. And in this section, we're going to be taking a look at how to put numbers in scientific notation, how to take them out of scientific notation and put them in standard form, and then how to perform various operations with scientific notation type numbers, such as multiplication. We're going to be doing division. And I wanted to start by just reminding you, because this is an important part of dealing with scientific notation, that there will be a coefficient, there will be a base, and there will be an exponent. And that is what you're seeing a picture of right here. This is known as the coefficient, the number out front. This is called the base. And then your exponent is always attached to the base. It's just the names that you're going to be seeing whenever someone talks about exponential notation. We get into a conversation about base and exponent and coefficient, especially when you go to do the multiplication and division problems. So in this problem, the coefficient only happens once, and then what this means is that the base appears this many times in the form of a product. So you see that the x appears 10 times. They are in the form of a product. Product is just a word for multiplication. You see all those x's are repeated and multiplied by each other. We get to problem here, which I want to make sure that people are no longer making the mistake of thinking that this is equal to 10. It does not mean 5 times 2. It means the base repeats this many times in the form of a product. Product meaning multiplication. So this is not equal to 10, it's equal to 25. You will have a power key in your calculator. Mine looks like this, and on the TI-30s, they look similar. It might be the same exact one, which it is on a lot of them. It's just a little caret key as a power key. Some calculators will have either this, and hopefully everyone knows that this can be called an exponent, but can also be called a power. So I may refer to it as the power key. So in a lot of calculators, when you want to raise to a power to get this answer, you would just go base, use the power key, and then whatever the power is, you would enter that in and it would give you 25. Some calculators, if you don't have the TI-30, you would have 5 and then maybe a key like this, which says I just entered the base. You enter the base first, then the key that's used is the power key, and then tell it what the power is. So you would then feed in the 2. Okay, so there's always the base, whatever key is being used as the power key, then the exponent, and it would give you the same answer. Okay, so just a little bit of calculator stuff. Okay, moving on to properties of exponents. So you're going to be using these when you go to calculate any kind of a product or a quotient. Okay, what this says is that when you are multiplying exponential expressions, the bases have to be the same, and in that case, it will be the base. Copy that common base. Do nothing with the base other than copy it. And then the rule for multiplying is that you're going to add the exponents. So when multiplying, add those exponents. So it's going to be 3 plus 50, 53. I'll write out what I did before that. Doesn't matter whether you write 3 plus 50 or 50 plus 3. Just add the exponents, and this would be your final answer. 10 to the 53rd. When you're doing a division problem, then you're going to subtract the exponents. And there is a specific order here. Whenever you have, and the bases again have to be alike, just copy the common base, and it has to be top power minus bottom power. Must go in that order. Okay, so this ends up being 10 to the 9th power. And this is our final answer here. This is our final answer here. Okay, moving on to each of these, just making sure that you know how to expand properly and get an answer by hand. You can use your calculator to assist. But if you're asked to show the expansion here, this would be 10 times 10. This base, 10, appears this many times in the form of a product. That's equal to 100. And notice that the power dictates how many zeros you have on your final answer. 10 to the third would be 10 times 10 times 10. So when you're multiplying these, you could just go 1 times 1 times 1, 1, and put that many zeros on it. 1, 2, 3. 1 from here, 1 from here, 1 from here. 10 to the negative 1, you may want to use your calculator, but there's also a way to think about this where you don't have to use your calculator. Anything with a negative power or a negative exponent, you could call it either way. Negative exponent is really written, it is defined as a fraction. That's what negative exponents mean. That you're going to rewrite this as a fraction, and when you do so, it takes away the negativity of the power. In fact, sometimes the directions are going to say rewrite this without the negative exponent. So it is always, when you rewrite these negative exponents, 1 over whatever the base is, put that base there, and as you bring this, because 10 to the negative 1 is the same thing as 10 to negative 1 over 1. So right now this is in the numerator. The minute that you drop it to the denominator, the exponent goes from negative to positive. So that's really what that is, written without the negative exponent. The same thing as 1/10. I'm just writing it without the 1. And 1/10 can be written as the number 1 in the tenths place. Remember that we learned on the very first day of class the names of the various place values. The tenths place is the very first space or the very first digit after the decimal. So this would be 1 in the tenths place. 1/10 is written like that. And you can put the leading 0 here. That's how it's typically written. Okay, here it is. We're rewriting a negative exponent. So it's 1 over, take that base, bring it down to the bottom, and switching it from the top where it is now down to the bottom makes that exponent convert to a positive. Okay, that is the same thing as 10 times 10 times 10. We looked at that over here, is 1,000. So this is going to be a 1 in the thousandths place. Anything that's, any kind of number that's less than 1. 1/10 is less than 1. 1/1000th is less than 1. Means that it's going to be numbers on the right side of the decimal. So this is a 1 in the thousandths place. So it goes tenths, hundredths, thousandths. A 1 in the thousandths place. So this is the same as 1/1000th. And you can put this in your calculator. You know, if you go 1 divided by 10, see, you get 0.1. If you go 1 divided by 1,000, you get 0.001. If you're trying to do it by hand, that is what this means. A 1 in the tenths place. Well, the first number after the decimal is a tenths place. This is a 1 in the thousandths place. Okay, and so those are your final answers for these 4 examples. 100, thousands, and this is the work that supports it. You want to try and, you know, get your procedures together for learning how to show work. You're going to show what your thought process is. Don't just do everything by a calculator. That will not be acceptable in this class. So we're trying to show that we have the skills to work these out by hand. Okay, so now we get to actual scientific notation, where you're going to be converting numbers either into scientific notation or going from scientific notation back the other way. Now they've given you some rules to follow here. I'm going to write those in my own words as we do the problems. Okay, so the very first thing that you want to look at when you're converting into scientific notation, this is called standard form, when you don't see a base of 10 or an exponent. You don't see any of that here. You just see a regular number. This is 730,000, and you're going to put it in scientific notation. So the first thing you want to identify is the number that you're starting with. Is it greater than 1 or is it less than 1? Because that's going to determine the sign on the exponent. So notice that this number is greater than 1, the particular number. So what happens is that means that the exponent that you're going to come up with when you move into scientific notation, that exponent is going to be positive. Okay, so the first thing to identify after you realize that what kind of exponent you're going to have, positive or negative, is where's the decimal? Because to move it into scientific notation, you have to move the decimal. Move the decimal until you're in a spot where there is one non-zero type. It can't be a zero. It has anything but zero. One non-zero digit to the left of decimal. Okay, that's the moves you're going to be making. You're going to move that decimal until there's one and only one non-zero type digit to the left of it. So your decimal is right here. When you don't see a decimal, it's said to be all the way at the end of the number. So you're going to continue moving. 1, 2, 3, 4, right in there. 5 places. I stopped moving the decimal at the point where there is one non-zero type digit, the 7, to the left of the decimal, and then everything else is to the right. So my scientific notation answer is 7.3, and you can leave off all these zeros, because I mean you could write 7.30000, but really it's just fine to leave the ending zeros off. Then you want to show that this is multiplied by a base of 10. All scientific notation numbers are multiplied by a base of 10, and then this exponent on the 10 has to do with how many spaces you moved. You moved 1, 2, 3, 4, 5 spaces. And since you moved 5 spaces, that dictates the exponent. Okay, and as I said, when the number starts off greater than 1, that exponent will be positive. Okay, so just talking about how to determine whether your exponent is positive or negative, and where to move so that your decimal is considered to be in scientific notation form. Okay, notice that this one, in contrast to the first example I gave, this number is less than 1. So we're starting off with a number that's less than 1. Therefore, the exponent is going to be negative. Okay, so when your number starts off as a number greater than 1, your exponent will be positive. And when your number is less than 1, your exponent will be negative. Okay, this time we can actually see where the decimal is because they showed it to us, but when they don't show it to you, then you just place it there yourself and begin moving. Okay, remember the idea is to move the decimal until there is only one non-zero digit to the left of the decimal. That means I got to move this way. So I'm going to move 1, 2, 3, 4, 5, and 6. The minute that I get the decimal in there, I do have a non-zero type digit, the 1, that's on the left of the decimal, and then everything else is on the right. So this becomes, with the decimal right in there between the 1 and the 0, it becomes 1.04. I couldn't leave all of these off because they weren't all zeros, as was the case with the first problem that I did. So exponential notation, multiplied by a base of 10 raised to an exponent. The exponent will be negative, and the number that it is has to do with how many spaces you move. So in this problem, we moved, one more time, 1, 2, 3, 4, 5, 6 spaces to get it properly placed. So this will be a 6, but it'll be a negative 6. And that's because this number ended up, the number was less than 1 to begin with. Okay, moving on to problems where we're going back the other way. In this problem, it's already in scientific notation, so we have to kind of reverse our thinking. If this is a negative exponent, right here, what that negative exponent indicates is that this number began as a number that was less than 1. So right now you're looking at something that's bigger than 1, that coefficient right there. So you want to move the decimal in a way that you're going to end up with a number less than 1. So if we were to try and work on this number to get our final answer, we see where the decimal is. We know that this number that's playing the role of the exponent is the number of places that it was moved in order to get it like this. Now, if I was to move the decimal this way, it would get bigger and bigger. If I moved it around the 6, it would become a 56. It's getting bigger and bigger. You want it to get smaller and smaller when you know that it was a number less than 1. So we're going to actually move it this way. And this is how many spaces you're going to move. You want to move 7 spaces. And the only way this number is going to get smaller and smaller and smaller, ending up to be a number that's less than 1, is if you move to the left. Move that decimal to the left. So I'm going to move once around the 5, and I got to move a total of 7 spaces. So 1, 2, 3, 4, 5, 6. The decimal would end up right here. And all of these spaces that there were no numbers for, you fill in with zeros. So once around the 5, 2, 3, 4, 5, 6, 7 spaces total. Put a 0 in there, 0 in there, a 0 in each of these spaces. And then we can just write it, nice and cleaned up. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, and we had moved around the 5 as well. The decimal's no longer there. It's at the end with the 6. So when you bring it back into standard notation, you will no longer have the base of 10, nor will you have the exponent. Okay, another one like this. Okay, notice that this one has a positive exponent, which means it was a number much bigger than this. And you want to continue making this number bigger than it really appears. So if it's a positive exponent, it's definitely going to be a number greater than 1. In fact, it's going to be bigger. When it is a negative exponent, it looks smaller than it appears here, than that coefficient appears. This is a 3.4. I know that's already greater than 1, but it's really going to be even bigger than that. If you were to take this decimal and move it 8 spaces to the left, you would end up with a number less than 1. So positive exponent, you want to end up with a number greater than 1. That should stop you from moving the wrong way. Okay, so I'm going to take the 3.4 and we're going to move 8 spaces. And we're going to move 8 spaces to the right. Okay, so I'm going to do that over here. Let's see, I'll do some of the work right here. So 3.4, I want to take that decimal and I want to move 8 spaces to the right. Because again, if I was to move it 8 spaces to the left, I would end up with a number less than 1. This number needs to be greater than 1, which you can tell by the positivity of the exponent. Okay, so I'm going to move it once to get around the 4, and then I need to go a total of 8 spaces, so I need to move 7 more spaces. 1, 2, 3, 4, 5, 6, 7. Decimal ends up right there. So fill these in. 1, 2, 3, 4, 5, 6, 7. Transfer that number over here. Decimal's no longer there. It's at the end. 1, 2, 3, 4, 5, 6, 7. You can put those commas in. So that's 340 million. Okay, moving to computing with scientific notation. There's quite a bit of this in Alex, the test, so I'm going to help you with, I've already talked about this, how to put it into the calculator. If you did want to put a scientific number in the calculator, I'll be demonstrating these as I do the problems by hand and also by calculator. Your calculator can really serve, like for instance, let's say, well, let's just get to the problems, because as I get to the problems, rather than me making them up, we already have some nice examples here. I will also demonstrate how to put in the calculator. Okay, by hand. If you want to do it partially by hand, it was said there was a couple of rules that you were given on a previous page in this section. And it said when you're multiplying, this is all multiplication. You see nothing but multiplication symbols. So how do you go at it when you're doing it partially by hand instead of putting the whole thing in the calculator? You would multiply 5 times 2.9. Those are the coefficients. So I'm multiplying that times that. Which would be 14.5. And then as far as these bases go, right here, if you're multiplying 10 to the 18th times 10 to the negative 4th, when multiplying, you add the powers. When you're multiplying like bases, the bases are alike, make sure to add the powers. That is the rule for multiplication of like bases. Okay, so this will be times, we're given an answer in scientific notation, times 10 to the 18 plus negative 4. So this would be 14.5 times 10. This plus this is 14. Now I know you've done basically all the operations, but the only problem with this answer is that, and not that all of them are going to come out like this, you have to look at them and make sure that they are in scientific notation, just because part of the points would come from that. This is not scientific notation, because when something is scientific notation, there's only one number on the left side of the decimal. You have 2 numbers. So a way to alleviate this by hand to correct it so that it is in scientific notation is move it over so that there is only one number to the left of the decimal. So the decimal would now be here. And if you find yourself moving 1 space, then you're going to add 1 to this power. So what really just happened here is you made the 14.5 that was here, you made it smaller, and therefore you needed to compensate by making this power bigger. Okay, you made this smaller by 1 space. If you had to move it 2 spaces, you would add 2. And therefore you have to compensate on the power. So this would end up in scientific notation as 1.45 times 10 to the 15th. You can also get this in the calculator, as I was about to demonstrate on the previous page. This is how you would enter it in the calculator. It would just be 5 times 10 raised up to a power of 18. Okay, that's one number. and we are multiplying that scientific notation number times another scientific notation number, which is 2.9 times 10 raised up to -4. And notice that it gives you the answer. It doesn't show the 10. This is the kind of notation. You are not to give your answer like that. You have to understand that this e to the 15th, that means times 10 to a power of 15. So know how to interpret that. 1.45 times 10 to the 15th, positive 15th, which is exactly what we got when we adjusted our answer in order to make it in order to give the answer in scientific notation. Okay, next we get to a quotient. And in this quotient, quotient means divide. You can attack it the way that I did in the last problem. You can work just with the coefficients. In this last problem, it was multiplication, so we were multiplying those coefficients, the 5 and the 2.9. This one's division, so we're dividing the coefficients. 24 divided by 4 is 6. And then you need that base of 10, and then you learned on a previous page that the rule for division when you're working with like bases is to subtract the exponents. Subtract the exponents when dividing. And it has to be top exponent minus bottom. Okay, must be top minus bottom, as I indicated on a previous page when we were looking at that, when we were, taking a look at that rule. Okay, so I already did 24 divided by 4. That's where I got this from. 24 divided by 4, that gave me that. And then as far as the multiplication by base of 10, we want to get the exponent. It is top power minus bottom power. So this is 6 times 10 minus 9 take away 7, negative 9 take away 7. When you're pressing this in your calculator, just make sure you're doing it right. The first number that has a negative has to be entered like this with this negative. So it'd be negative 9. And then for the second number with its minus, it's minus 7. You get negative 16. Now this is already in scientific notation, and that's because 6 is the same thing as 6.0. And you can see that there's only one number on the one non-zero type number. It can't be a 0 that's over here. You move the decimal so that you have one number that's not a 0 on the left side of the decimal, and only one number, and this is already like that, so no adjustment needed. Okay, if you were going to put this in your calculator, I would put, when you're doing a quotient, I would put parentheses around the top and the bottom because there's several operations. There's more than one operation happening here. Okay, so on the top, I open up a parenthesis. My number on the top was 24 times 10 raised up to, I have to put the multiplication symbol in there, times 10 raised up to a power of negative 9. Close it. Divided by to get that fraction bar, and then in the bottom you were dividing by, put this one in parentheses too, 4 times 10 raised up to a power of 7. Close the parenthesis, and it'll give you that same answer, 6 times 10 raised up to a power of negative 16. Okay, since this seems to be a little tricky for students, here are some more problems to practice with. So I'm going to do this first. 15 divided by 3 is 5 times 10. Exponent on my base of 10. Remember, when you're doing quotients, you must subtract these powers, and it must go like this. Top power minus bottom power. Okay, this is just equal to 5 times 10 to the third. This is already in scientific notation because 5 is the same thing as 5.0. And as long as you have just one number that's not a 0 on the left side of the decimal, that's scientific notation. Everything, all the other numbers on the right side. And it's like that. So this is our final answer. Okay, moving to these problems here. We have some more to practice with. We have 9.28 divided by 2.9. So that you're going to want to consult your calculator with. It's just it's sometimes just much easier just to do it in parts. Just do the parts that you need in the calculator rather than putting the entire thing in the calculator. I mean, it's good to know how to put the entire thing in there because you can use your calculator as an answer key. But if I was going to do 9.28, which would be too much of a hassle to do by hand, I would just do that divided by the 2.9 in the bottom. I would get that 3.2, so I'm not turning this into a tremendous amount of work, but still showing that I did the division. And then I can show a little bit of work here. I can show that I understand what the rule is for how to deal with the exponents when you're doing division. The rule is to subtract, so you could show that, and that could be your work. So it's top power minus bottom power. This ends up being 3.2 times 10 to the negative 9th. And this is in good, perfect scientific notation because the coefficient only has one number to the left of the decimal. That's already in scientific notation. Moving on to number 3. We have another multiplication problem. Again, this might be just, a little bit too much work to do that. You can do it by hand if you like. I'm going to do that part in the calculator. This is 9 times 2.4. And that is 21.6. When you multiply those two, 21.6 times, now we're multiplying, so here you're going to add the powers when multiplying. Here we subtracted the powers. Okay, so it's going to be 10 to 7 plus negative 1. Adding those powers, that gives me 21.6 times 10 to the 6th. And then this is not in scientific notation because the coefficient right here has too many numbers on the left side of the decimal. You need to move this into a position, the decimal, so that there's only one number to the left, the rest of the numbers on the right side of the decimal. And if you are going to make this coefficient smaller, it used to be 21.6, now it's 2.16. So if you're going to make this smaller by moving one space left, then you need to make this bigger by adding 1. The number that you add here is dictated by how many spaces you moved here. I moved one space, therefore I added 1. So the answer in final form would be 2.16. Coefficient is now in perfect scientific notation form, and the exponent on the 10, because I'm adding the 1, ends up being 7. And you can even put that in your calculator to verify that that's the final answer. But in this way, you can show some work. Okay, so if you were to put this all in the calculator, it just would be 9 times 10 raised up to a power of 7, close that parenthesis. And then you could put a little multiplication sign, but when you have parenthesis times parenthesis, that also means multiplication, so you really don't have to. Second parenthesis, 2.4 times 10 raised up to a power of negative 1. Close the parenthesis, and look what it gives you. See, it gives you something that's not in scientific notation. It just gives you the standard form answer. You may be able to set your calculator to give it in scientific notation, but if you were to put this in scientific notation, this would just be 1, 2, 3, 4, 5, 6, 7. 2.16 times 10 to the 7th, which is what we already got. I think it's less work to do that. Okay, moving on to number 4. You have 2 times 1.8 if you multiply those coefficients. So multiplying these two right here. 2 times 1.8 is 3.6. Perfect. That coefficient's in scientific form. And then, since we're multiplying, we're going to add those powers whenever you're multiplying. So times 10 to the negative 7 plus 6. So it's 3.6. Negative 7 plus 6 is 10 to the negative 1, and that's your final answer. And then, of course, I've shown you how to put these in the calculator, so you can always check them there. Okay, here we're going right back the other way. What we did before we started multiplying and dividing, we just have a standard number. There's no base of 10, no exponent on the base or anything like that, so this is called standard form. Decimal is not to be seen. You don't see where it is, therefore it's at the end. You're going to move it until you have one number on the left side of the decimal. So it's going to be 1, 2, 3, 4, 5, 6, 7. So that 3, the decimal moves right in between the 3 and the 6. This number started off greater than 1, therefore my exponent is going to be positive. Okay, then this number here, you can see that this number is less than 1, therefore my exponent is going to be negative here. So number starts greater than 1, exponent will be positive. And the number starts off less than 1, the exponent will be negative. Okay, so we're going to take that and move it till there's one number on the left side of the decimal. 1, 2, 3, 4, 5, 6, 7, 8. So this ends up being 5.8 times 10, and we moved again 1, 2, 3, 4, 5, 6, 7, 8 spaces to get that decimal between the 5 and the 8 so that there's only one number on the left side of the decimal. This is going to be 10 to the negative 8th, and that is your final answer there. Okay, that concludes the examples in lecture 4, lesson 1.7, MAT 1100.